Hello and welcome to a new In the Mail. This one is shot from the new Voltlog lab. I haven't finished setting everything up in here, so the sound and lighting might not be to the same level that I had before, but please bear with me, I'm working on solving everything. Since I haven't installed all my equipment, I thought it's better if I do an In the Mail episode, so let's get started. Right from the start, I'm going to tell you this episode is dedicated to connectors, wires and switches. And to get started, from the left I have a set of two pieces 90 degrees angled RP-SMA male to female adapters. I mentioned in a previous video I am getting back into the RC world. I'm currently building a flying wing with an FPV system, so I will need this kind of connectors on the video transmitter to install an antenna angled at 90 degrees. Next up I have some RP-SMA female and some male connectors. These are perfect for terminating the RG402 coax cable. So I will use these to build some antennas for the 5.8 GHz frequency that the FPV system uses. I have already ordered some PCBs for the pagoda antenna, but those will get shown in a future video after they arrive. I also got some SMA female connectors. These are crimping type connectors for RG58 cable. I was thinking I could install an antenna for my Baofeng radio outside my window. Even though these connectors are not rated for outdoor use, I could still run some tests and see how the system works before moving to something more rugged. And the last one is an SMA male panel mount connector. I figured this could be the base for my antenna, and then various SMA terminated antennas could be screwed into the base. So I basically got a bunch of cheap eBay RF connectors to do some experiments. I also got this rigid coax RG402 type, like I mentioned previously, for building some antennas for the 5.8 GHz, specifically the pagoda model. As usual, links for all of these items will be in the description below. Next up I have some parts that were originally intended for the Raspberry Pi April Fool's video. If you haven't seen that video, I recommend you watch it. It's a pretty cool project. I will place a link in the upper right corner right now. So I have some USB Type-C surface mount connectors, but I didn't get to use them. I got some USB 3.0 connectors. These are dual stacked ones, the type that you usually see on computer motherboards. And some 3.5mm stereo jack sockets. Initially I didn't know what the full set of features on that board will be, so I ordered different types of connectors, but ended up using just some of them on the final design. These ones coming from China arrived quite late after I released the video, so now they're just going into the connectors storage container, waiting for a new project to give them a purpose in life. Next, these are some 0.1 inch pin headers. They should be 40 pin count in length, and as you can see I got these different color options. When assembling a particular project you can color code your pin headers, and it will look much nicer. You can even match this with the color of your solder mask, things like that to make a board prettier. I also got a bunch of these 4-pin screw terminal connectors, and these are nice because you can have one end attached to your cable harness and the other end soldered onto the PCB. They are inexpensive and you can find them pretty much everywhere, but if you plan on getting them cheaply from China, plan ahead and order yourself some of these because in my case they took a while to arrive. I also got some of these cheapo 3.5mm stereo jacks. I like to call these disposable connectors because they're very low quality, so I would only use these for testing and prototyping. You wouldn't want to use one of these on your headphones or anything that will have to survive more than 50 mating cycles, let's say. I also got a couple of these gold plated ones. Yeah, right, like these have seen gold. I'm pretty sure these haven't seen gold in their life. This is of course not gold plating, but at least they have this yellow shine to them. And they have this stress relief spring on the end, so they just feel a bit better than the previous ones. In here I have a set of 10 pieces 2.5mm DC jacks for panel mounting. These are great for all hobby projects that need external DC power. You can use one of these on the back panel, and with an external power brick you send power to your project. You've seen me use these on nearly all of my projects, so I got another set of 10 for future projects. I wasn't kidding when I said it's going to be all connectors and wires in this video. Let me know what you think in the comment section. Is it better to group items like this in a video, or would you prefer a more mixed content in the mail? Next up I have this DB9 gender changer connector. Sometimes you have a female connector on the target device and also a female connector on the USB to serial dongle or whatever, so you need one of these gender change adapters just to connect everything together. One of these is fairly inexpensive, so well worth keeping it in the lab for when you will need it. Next I bought 4 pieces of these nice chunky 4mm banana connectors. Even though they accept 4mm banana jacks, they have an M5 thread on the back, so they feel really nice and sturdy. Also they're higher power than the cheaper smaller ones, so it might be a good choice to use a set of these on your DIY dummy load or high current power supply. This time the seller was nice enough to send me 2 red and 2 blacks. Always specify this when placing an order, because otherwise you might get all 4 the same color. And to finish up with the connector section, I have some 18650 battery sockets. These are surface mount sockets, meaning you can design a PCB to hold these. You could of course solder wires to the end tabs and use them anywhere, but their purpose is to be used on PCBs surface mounted. This way you avoid the extra work of soldering wires to these connectors, and by not having any wires you also remove a weak spot from any product, because wires and their solder joints are more likely to fail over time than a surface mount soldered connector. Now let's move on to switches. I have a bunch of switches to show you, but first let's start with these small ones. These are normally open single pole, single throw reed switches. This means their contact will close in the presence of a magnetic field, and I can easily demonstrate that with a multimeter on the buzzing test. So let's connect the multimeter to one of these switches, and then I'll grab a magnet and show you what I mean. So right now the connection is open because this is a normally open switch, but as soon as I move a magnet close to the switch, you'll hear the switch closing. This type of switch can be particularly useful in a variety of applications where you want to detect the presence or position of an object without any contact. So you could have one small magnet on a door, for example, and you can have this switch detecting if that door is closed or open. Next I have some tilt and some vibration switches. I have 4 types here, and honestly I have forgotten which is which, but I have about 4 different types in here. The main difference is that a vibration switch should detect movement on pretty much all axes while a tilt or ball switch should only trigger on a certain axis. I bought 4 different types because I wanted to replace the one in the handle of my STM32 soldering station, just to make it more sensitive and trigger on the slightest movement on the handle. You know, for the standby function I mentioned in the video I did for that soldering station. I'll have to experiment with this and see which one I like best. Maybe I'll do a separate video on that, but right now, since I have the multimeter on the bench, we can test a couple of them. This one seems like it's a ball switch, and it's a tilt switch. As you can see, it triggers when I rotate it 180 degrees on its longitudinal axis. This one seems to be the same type, so it only triggers in this position. Maybe less sensitive than the green one. I don't want this kind of switch, I just want a vibration switch to trigger on movement on any axis. This one, I think it's a vibration switch, because we can see the screen of the multimeter changing, but I don't think it's very sensitive. So I think it needs quite a lot of force, but yeah, I think it triggers on movement on any axis. So this one might be a good choice for the soldering iron. And let's test the last one. I can clearly hear the ball inside this one. Yeah, so clearly a tilt switch. When it's in its when it sits in the vertical position, it triggers the contact. So I think I have only one good candidate for the soldering iron handle, but more testing will have to be performed. As usual, links for all of the items shown in this video will be placed in the description below, so don't forget to check them out if you see something that interests you. Next, I got a pack of rocker switches. These are the smaller type, great for small enclosures. They are rated for 3 amps at 250 volts, but I wouldn't push that rating to its limit. Play it safe. You never know if the Wanhang Low factory in China really tests these, or if they label them optimistically without any safety testing. Like I said, great for small enclosures, small projects. I'll probably use them on DC only, up to 30 volts, up to maybe 1 amp. These are dirt cheap, so I always keep a 10 pack in the lab. These ones are also rocker switches, but with a round profile, so these should be easier to install on a front panel, because you can just drill a round 18mm hole instead of messing around with the Dremel and creating a rectangular slot like you would need for the rectangular switch. These are rated for 6 amps at 250 volts AC, and they feature 3 contacts. I have them in 2 variants here, one with just an on-off switch, and this other one with 3 positions on the switch. These should be useful on slightly bigger enclosures, because as you can see they take up quite a lot of space. Next, I have some of these very small slider switches. They're great for low power small projects like the Bluetooth receiver that I built a while ago. I was missing one of these small switches back then. If you haven't seen that video, there will be a link on screen right now. But the point was I had a small tight enclosure and I needed a very small switch, and I didn't have one. These are 5 volts 0.3 amps rated, so you use them only for low power applications. Next I have a set of these small latching clicky switches. These are similar to the types found in flashlights. They feel pretty nice with a good tactile feedback, and the nice thing is that they're latching, so once again good for small projects where you want a latching switch on the power input, for example. They're rated for 1 amp at 30 volts DC, so make sure you don't exceed that or the switch might melt. Next I have another type of latching switch, and these remind me of the old motherboard or ATX cases. They all had one of these on the power button. These ones have 6 pins, and by looking at the technical drawing, I will insert a picture on screen right now, we can see they have 2 independent contacts on each side. One is normally open, the other one is normally closed. So it's quite versatile. You can connect them in many different ways. These one are momentary switches. I'm not sure exactly if these are normally open or closed, but let's test one with the multimeter. So it looks like they're normally open, and they only close momentarily while the switch is pushed. These are some pretty slim switches. So I think they have a 6mm shaft. You can easily drill a 6mm hole into your front panel and install one of these. So they're great for ease of mounting. And to finish off the switches, I have these 12 by 12mm tactile switches. What's special about them, you might ask? They have an LED, hence an extra pair of pins on the side. So you could also signal the status of this button using a transistor and a microcontroller pin, which is quite nice and necessary in some projects. I saw these on Andrea Spice's mailbag video a while back and decided to get a few just to check them out. Let's apply power to one of these LEDs from my bench power supply and see how they look. I have the power supply set for 2.5 volts. Okay, so they look pretty nice. Let's test another color one. Yeah, so Murphy gets me every time. I get the polarity the other way around. This is how the blue one looks. A bit less brighter than the red one. I'm not sure if they actually use colored LED inside or they just use white LEDs and different colored plastic. This is how the orange one looks. Let's also give the white one a try. Yeah, so you can see the white one slowly turning on as I increase the voltage. So indeed they have colored LEDs inside, so you would need to match the voltage and current to the particular colored LED you have inside. So for the white one you would want slightly more than 3 volts, and for the red one it works with 2 volts, 2.5 volts. So yeah, you need to adjust for that. And I almost forgot about these. They also belong in the switches section. They are thermal bimetallic switches. I've shown these before in previous episodes, but this time I got a different temperature rating. They are 50 degrees Celsius metallic jacket, normally opened. This means I can use one of these switches to automatically turn on a fan on a heatsink once the temperature of this switch reaches 50 degrees Celsius. Be careful though, the metal jacket might be connected to the contacts of the switch, so you need to insulate the switch from the other electrically conductive parts of your circuit. Okay, so now that we're finally done with the switches, we can take a look at some wires. First I have this black and yellow 24 AWG bundles. I already had red and blue. I've shown those in a previous video, but sometimes you need more than 2 colors on a project just to get everything nicely organized. So I got these two as well. They're not silicone wires, but they're nice and cheap, and you can't always use silicone wire because those are more expensive and really not required in every application. Next, I also got some 24 AWG silicone wires in red, black, green, yellow and blue. These are a bit nicer, more flexible. Let me give these a feel. Yeah, definitely flexible. And most importantly, they withstand a higher temperature, usually 300 degrees Celsius. This is especially useful when soldering them. Slightly more expensive than the regular wires, but worth the money when you're working with a higher temperature and you also need the flexibility of the wire. Next, I got some of these so-called special wire for jewelry, but I don't intend to start making any DIY jewelry on the channel, and not in my personal life anyway. Instead, I thought I'd try this one and see how it takes solder. I got two of them, 0.4mm and 0.8mm. So I'm curious to see if it takes solder, because then I could use this to make jumpers on the DIY PCBs and build bus bars and things like that to increase the current capability. I could use it to route tracks on prototyping perforated boards, but all that only if it takes solder. So let's give this a test with the soldering iron. I have my iron set to about 300 degrees. So let's see how it will take solder. Wow, it's very nice. It took solder really fast, and it looks like it's very easy to solder. So I will be using this wire for future projects. I think it will be really useful to have a couple of these in the lab. As I was browsing around AliExpress, I came across this nice braided cable with different colors. I say nice because of the colors and not necessarily for the quality of the cable inside, which I'm sure it's not that great. But you can get these in many colors, and they're intended for those hanging lights to create a nice effect with different type of colors. I think I have 1 meter in here, or maybe 1.5 meters, and I intend to make myself a retro type lamp, and it should look quite nice with this neon blue cord. And to close this in the mill episode, our last item is 1 meter, I think, of this heat shrink tubing, a rather large diameter. You wouldn't use this one very often, but I needed a piece in this size, which is about 26 or 27 millimeters in diameter. I always keep a bag full of various sizes of heat shrink tubing, but it seems I always find myself lacking the one I need in a particular project. That was all for today, quite a lot of items. Please let me know what you think about this video in the comment section, and show me your love by hitting the like button. Don't forget, links for all the items are in the description below, and I work a lot to create those links and shortcuts, so please use them if you see anything interesting. I will see you next time, hopefully with a better setup.